Howdy, my name is Billy Lee. I am in ENEA 380 in section 104. This is my final project called PyTanks. It is a PyGames tank game where two players or player computer fight against each other and try to destroy the other tank. Initially, we're going to start her off at level 1, and let's go ahead and get into that. As a disclaimer, it is running somewhat slow due to the fact that I have a screen recording software running alongside it. It's normally, I'd say, about 50% faster than this, typically. Like I said, we're going to play the computer, so let's go ahead and select computer. Now, I'm going to call out the missiles as it goes along. So this was a simple missile. I'm the green tank, by the way. And it is just follows standard trajectory. This next missile is also follows standard trajectory, and that would be that large missile flying down. So another one coming. And if you look in the top left, you'll see player option 1. That lets you know which missile is coming in next. So the next missile I'm going to fire is simple missile again. The blue bar underneath is the cooldown. That way you can't just spam a bunch of weapons off rapidly. The next missile, you won't see it fire from my gun. It is firing from the sky. It was that tracking one that followed him everywhere he went. So far I'm winning. It is level 1, thankfully. So it is kind of easy. I'm about to get a health boost. Bam. There it goes. You can go over 101, and here's a speed boost. Not that big of a difference, but it does help out a lot. The majority of the missiles will either be simple or big, whilst the enemy right now is firing hellfire. All of this into the sky that's falling down, that was him. And then there are random missiles that are just constantly falling at all times, like the one off to the right. And the speed just picked up out of nowhere. I'm assuming the screen's recording software is running a lot smoother now. This is normally what it is, the speed line. So this missile's tracking me. I'm going to go ahead and fast forward through this level, and we'll get into other options of the game. Okay, that was actually pretty close, surprisingly enough. I am out of practice. So, the screen will be locked in this position until you hit B, and then it progresses us to level 2, where the computer, surprisingly enough, just direct hit me, does a lot better. So, let's go ahead and cancel out of here, and let's go to player versus player mode. See, so now nothing's happening. I can control the left side, but with the ASDW keys, and then the player 2 can control it with the up, down, left, right keys and fire with control. That's pretty much all there is to this one. There are no levels in this option. It's just two players fighting each other. There's the tutorial. Gives you the movements for the player 1 at least. What to avoid, obviously missiles, how to control your turret, how to fire, and then what the symbols of the buffs are. Click on that, you can get back out of it. So we can go ahead and automatically place ourselves at level 10, right there. Go back to the computer, and as we can see, the computer's much faster, and all the random falling missiles are much more dangerous than they were before. And his aim is actually quite good. And honestly, I shouldn't say never. I've beat him twice on this level. So we're going to speed through this and see how that plays out, because I'm pretty sure I'm going to lose. And yep, I still lost. I did pretty well though, all considering. And then once you're at level 10 though, and you, let's say you win or you lose, it resets you back to level 1. So that was essentially all there is to the game, but there is one more option hidden within the code, not within any of the menus, where you can, here we go, computer versus computer. So on line 226, if you write this to be true, you get a pretty fun situation that goes on where you have a perfect computer, player 1, fighting the level 1 version of the computer. So we'll speed through and see how well the computer and computer do. So while player 1 was the perfect model, there is still a lot of luck involved in this game. Player 2 had a lot of heat-seeking missiles, which are guaranteed hits. And plus, the computer is not programmed to avoid, as you can see on the screen, that large cluster of missiles. They're not programmed to recognize that and to avoid. They're mostly just programmed to move toward the buffs. So let's say how that heart is above it. It wants to go into that area even though there's danger in that area also. And off to the left, you can see how there's all these statistics. So it made no simple missile hits. It got 1 out of 4 big missile hits. It was hit by the random falling missiles like this one here 5 times. It caught 6 of the healing buffs, and it caught 7 of the speed buffs, which is just a little fun thing. There's also this timer down here on the bottom, along with this timer numerical one. So this is the bar and this is the numerics. If that reaches 0, whoever has the least amount of health loses, and if it's a tie, then it also just ties the game. And that concludes how this program how this program looks whenever it's running and what you can do with it. So let's just go ahead and get at it. This is all the import libraries. We use math in here instead of NumPy. It's just a little bit easier, and it's built into Python to begin with, so the user wouldn't have to actually verify if NumPy was on there or not. OS we use for later on just to access some files. PyGame is the main engine that's going to be running it. Random for random numbers, and system for also some file acquisition stuff. We start by initializing Python. It's just a thing that has to be done in Python, and we are going to be using the font feature, so we're going to have to initialize that. The width and height of the screen is set 1500, 800. It can be changed. I have normalized a lot of the variables to fit different widths and heights, but it works a little weird, and this is the most optimal way to play it. So if your screen's small, I am very sorry. It might be a little weird when you play it. The window, setting it up for Python, and we're going to set the window title as Tank Game. We initially start off at level 1, and we're going to go ahead and start by gathering up a lot of images. So first off, the spinning tank in that main menu that you saw, it's going to be under this folder here, and it's going to be all of these images. So it's going to pull all of those out, and then we're going to sort it in a way that it is alphabetical or numerical. And if you ever played with these, you would know that 1 and 1, 1, it's kind of weird how it plays out because it's not in order. So we have to do the split text, all that, with the lambda to get it to actually go numerical and not just alphanumerical. If you understand, it's weird to explain. It's messed up if you don't do it that way. So now we're going to go into the setting the height and width of the tanks themselves, the images that move back and forth and shoot them. Like I said, I normalized a lot of these to be for different widths and heights, but it works best at what it's set to. Here, these are the options for the different type of missiles. So 1 is simple missile. So you got like, what is that, 5 out of 15 chance of those happening. The number 2 is the big missile. So you got 4 out of 15. 3 is the Hellfire, if I remember correctly. 4 is the tracker missile, so guaranteed hit, and then 5 is the jail, so restricts the enemy motion. And now we're going to go and import a lot of different images. These are underneath the assets. So the cursor, the bullseye cursor that you see in the main menu, the missile image, so that tiny bullet looking one, the big missile, which is modeled after, I can't remember if it was Little Boy or Fat Man, one of the two. The 2 different tank images, the fence for the jail, the health and speed boost images also. And then randomly we pick if we're going to use the nighttime version or the daytime version of the map. So that's settled there. So now we're actually going to start moving into the classes. We begin with the missile class. We're going to need its current location, what angle it was originally fired from, what image to use, the big one or the little one, and what type of missile is it. Is it going to be raining? Is it going to be the tracker and all that? And then what player fired it. They're all set to a certain speed, so a certain initial velocity, if you will, and they're all given a automatic 0 direction and positions. This is for the, I believe it's, we'll get to that in a second. That might actually be an artifact of something that was deleted. Masks, since I don't use the rectangular collision, I use pixel-based collision. I have to mask each image. So that way, if a single pixel of the missile touches a single pixel of the tank, it will be taken off. Or it'll consider that a collision. So we get this since the big one. All right, let's see. Sorry. Never mind. Yep. So that's for the missiles. Then we're going to go into the drawing feature. So simply enough, if it's missile 1, it's going to grab missile 1, and we're going to shoot. So this here, if player 1, sorry, it's going to blit it, which blit is going to be what actually casts it to the screen. We're going to rotate it by its axis, so that way it actually is in the direction of travel. This is really what sets it to look like it's actually going up and then going back down. For the other ones, it's quite the same. And then for 3, 4, and 5, it's just that. Yep. Hit ground. It honestly just lets you know if you hit the ground or not. It's really that simple. If the y coordinate is beyond the ground or not. If it's beyond the ground, it hit the ground. Move. This is going to be a straight line motion, so it's going to be based off its speed and its angle. The negative is due to the fact that, so here's the y-axis and here's the x-axis. X-axis goes 0 to greater than, and then y-axis goes 0 to greater than downwards. So we're not working in the 1 quadrant, we're working in the 4th quadrant if you're thinking about a Cartesian plane. Gravity, it's a time-based effector. It's going to, there we go, right there. The more time that increases, the more gravity will affect it. So it can do straight line motion at first, and then it's going to slowly be bogged down, and then come around here, it's going to be quite great, and it's going to bring it all the way back down again. And then this is what helps control our direction, which is, oh, sorry, these two are what controls the direction. Here's the time-based effector. So these would, your dx and your dy, you take the arctan of that, and then you can find the degrees at which way it's pointing. And then here's, sorry, the time-based effector, where it increases it, so pulling down plus, and the y direction is down, so it pulls it down. Falling is very simple. Set the direction of 270, which is straight down, and then the y direction is increased at a fixed rate of 6, normalized by the screen. So now we're going to go into the heat tracker, which we're going to need to know the time of it, but also because whenever we create these lines, we create them in parametric form. So there's a t component associated with that. But so we take the enemy's position, and through self we get its own position. Here's where we find its own direction based off of these equations. So these equations are formulated due to, we take 2 points. We take the enemy location here and then the self location, and we create a line between the two. With that line, we know its angle, and we know what direction it needs to travel, its rise over run. And so through that, we create this, which happens to be the line, the parametric form of the line, and we can adjust so instead of before how we were incrementing them, we're setting its variables to be the updated version. And it's updated dynamically, so as the enemy moves, it tracks the new location and it adjusts accordingly. Here, the collision for the missiles, it honestly just runs this. This could have been avoided if I did my classes correctly in the very beginning, but I got into a situation where I got way too far, and it was just easier to do it this way. So we'll be covering the collision after the tank class, whenever that definition is actually established. So now we're going to move into the tank class. First off, we got this cooldown. This is the timer this is the max timer associated with the cooldown of firing the missiles. So it's normalized to the screen width. This is the reason why it's that is because it has that little bar underneath the tank. But it's pretty much just 160 seconds. Sorry, not that. I think it's about 6 seconds or so of cooldown. But either way, this index is used for the explosion animation whenever the large bomb or the big bomb is going off. So we're going to start out with the tank's location, what image we're going to use, the missile images we're going to use. Those are kind of important. The angle that the current turret is at, which player this even is. The turret, which is we'll get into that whenever we initialize it. It's kind of hard to explain. And then a default 100 life. So that covers all the givens that the player or the user needs to give, but all of these are pretty much just baselines. You're going to start out with health here. Your option is you're going to start out initially with simple missile 1. You're going to start out not in jail, thankfully. You're going to have no missiles associated with you. Your cooldown 0, so you can fire. Your angle fire is set to 0, but that'll be updated immediately upon initialization of the game. Bomb flag is false. The bomb location, so these are the animations for the explosion. They're set to false, so it's not going to explode, and it's set to 0, but that'll change whenever the bomb goes off. It's set to automatically track the speed and heals, but that'll change the moment that one of them hits the ground. And speed is used way down here, which we'll cover later. These are just the trackers for if you were watching the video. At the very end of a game, you'll see, or if you're playing a computer at least, you'll see your stats. How well you did. Did you get hit by the, what's your hit rate, and between all the things, how many buffs did you get, that kind of stuff. So that's what all that covers. And like I said before, I use pixel collision, so I have to mask instead of using a rectangle perimeter. So we're going to go ahead and draw this first portion right here. This block is for the turret. It's all just to draw a little black line to show the angle of the turret at that current moment. It's quite simple. It takes the center of the tank here, and then it casts it to these XY coordinates, which are just, I want to say it's 50 pixels away. So we have a fixed 50 pixel length at an angle, and these are your sine and cosine, so your x and y values of those. Then we're going to go ahead and draw the tank, the cooldown bar, and the missiles to draw if there are any. So like this box here, if this array was filled with any missiles, it'll go ahead and cast those true. So pretty self-explanatory. We got the blit for the tank, and we have these two, which we'll cover later. They're definitions underneath the tanks class, and they just cast the health bar and cooldowns. Then also, if we're in jail, it's going to place a fence around us. So now we're getting into the firing portion of the class definition. So if it's 0, we can do any of this. So the cooldown has to go back down to 0, or we're not going to fire. So missile 1, we are going to, if the option was 1, so the first missile that we'll be able to fire is missile 1. So we'll take that as the example. We fire it. The second that we hit it, it will create this. It'll initialize a new missile with option 1. Player 1 fired it, and it'll give you the angle and all that, and the location. The location at which it needs to fire. They're offset in the Y direction, because if I fired it from the center of my tank, it would automatically count as a collision, and you would be hitting yourself nonstop. So we have to place it a little bit higher so it doesn't collide immediately. And this is more apparent with the large missile, where we got to add another 10 pixels so it doesn't hit itself. We then append it to that missile's array up top, and we track that we just shot a simple missile for the trackers to be used later. They all follow the same format. The rain missile has a little bit of a different step where it creates 10 different ones. So that's the only difference. And they're spawned way up into the sky, and then they're just rained straight down. So we got the counter 1, and that whenever this counter is above 0, there's a cooldown function down below, or cooldown definition down below, that once it's more than 0, it begins the timer again, and then it resets itself once it reaches it. And then, so once we fire the missile, we need a new missile in the lineup. So that's where this comes into play, where there it is. We choose a new option, and then we go ahead and cast that back to the main game loop, so you have a new missile to fire in the next one, and it's a random from that 15 list that we saw up above. So here now is the path. So this is just, it tells us the locations of the missiles at any given time. So this only works for 1 and 2, so the small missiles and the big missiles. So option 1. So these offsets are because it finds the center chords, because I wanted the tail, like let's say it's traveling like this. I wanted a tail kind of going from the center, because if you're not, you're just going to get the top rightmost image or top rightmost pixel, because that's what PyGame uses as a default. So this just tells you the location of the center of the missile at any given time. It is used in the trajectory parabolic arc like you see drawn onto the screen whenever you shoot out a missile, this is what finds those points. And it's as simple as, what is the point? And then just giving it back. And then a lot of if statements for which player and all that did it. So now we're going to go into how the missiles move. They were covered how they moved under the missile one. This one mostly just calls back to them. But it also covers the collisions in here too. So we're going to take it through all the missiles under this array. So we're going to go ahead and for, let's say, missile 1 and 2, for options 1 and 2, this is for those only. We're going to go ahead and hit it with some gravity, followed with that time parameter, and we're going to go ahead and move them. So it's going to get brought down a little bit and then pushed up. Brought down a little bit, pushed up. But it's going to happen every single frame that you're not even going to see like the step of it. It's just going to be a fluid parabolic motion. And so the first thing we're going to need to know is, did it miss and just hit the ground? Because we don't want it to travel forever throughout underneath the screen and then just bog down the system. So we're going to need to, if it hits the ground, which is that hit ground function that I discussed before, and it tells us yes or no, we see, yep, it did, okay, and we're going to remove it. That's all it is. And if it's that big missile, just for fun, we're going to create the explosion effect. We're going to set the bomb flag, the boom flag, to true, so it's going to start the animation, and then it's going to do it at that location, which is handled by the boom definition below, which we'll get into in a moment. And now we get into the player, collisions. We have, if the player hit a player, so object 1, I believe this is play yourself, if I remember correctly. So it tests if it hits you first, because if your method of winning the game is to constantly stay on the enemy and shoot directly up and like let it hit them, I didn't want that to be a case. So if there's a chance that it's hitting you, I want that to be the option that happens first, because there's no suicide bombers in the game. If you're gonna take out the enemy, you can't be taking yourself out with them. So it's gonna hit you first, not them, and it's gonna take away your health depending on which. If it's a big missile, 20, little missile, 100. Big missile, it's going to start the animation for the boom again. It's going to take, and since that missile's done, it's going to remove it from the game. And then same thing for if it hits the enemy player, life, boom, boom, and remove. And then we're going to go ahead and if the boom flag was set, which was these trues, it's going to actually do the boom explode definition, which is right here. So we're going to go create this boom images, a collection of images, of all, I want to say it's 6 of them under here. 7, I guess, counting the last one. And then we're going to index them in order as we did before, and then we're going to, where is it at? Do one at a time. And then we're going to index this way, so that way it's not as like this essentially controls the timing almost, and then we just kill it so that it just doesn't constantly keep going forever. So now we're going to get into the option 3, the Hella Rain missiles. It's underneath the rain. So again, it's extremely similar to the simple and big missile. You're going to have object 1, player 1, object 2, player 2, or actually, I suppose the correct way to say it is the player who fired the missile and the enemy player. It's going to hit it with the fall, which is just downwards motion, so no more straight line motion before with the angles involved. It's just straight down of a constant rate. If it hits the ground, remove it. Hits player 1, take away health, remove it. Hits player 2, take away health, remove it. So that's as simple as that. The heat-seeking one, we're going to need that time factor and player who shot it, player who's the enemy, and the enemy location. And so we're going to feed that into the missile track that we covered before. It's going to track to them. There's a really good chance it'll never, ever hit the ground if, considering it's designed not to, it's designed to hit the player. But in case it somehow misses or does anything weird, it should remove it itself. But what's interesting about this one is, although it's a guaranteed hit on the enemy, there is one way to get away with not getting hit by this, which is stand directly in the location of the person who fired it, because they will get hit first and it will remove the missile before it counts for you. So, little tip if you ever want to try to actually beat the game. Here's that cooldown function or definition that I've been mentioning a few times now. Like I said before, if it's ever a number, really, it'll just... Well, sorry, if it's going to count up forever until it hits that cooldown. Where did it go? This number right here. So once it's past that number right there, we're going to... Where did we go? Sorry about that. There we go. Sorry. Yeah, if it's greater than that, we're just going to set it to 0. So then it's just going to chill at 0. We can fire. And then, but if it's ever greater than 0, so whenever we set it to 1, it's just going to add 1 to it until it reaches that cooldown, sets it back to 0, and then we're ready to fire. And that's how the cooldown is tracked. So here, the health bar is pretty simple. We just draw a rectangle. What is that, red, below the player. So it's at their player's location, plus 10, so work down 10. So it's going to follow them around, and that's that. That's the big one, so the one that will always stay the same size. And here's the partial bar that will slowly get smaller and smaller. And it's same location, so that way it overlays, but it's kind of like, what should I say? The x direction of it is like its width. Sorry, the width is diminished by a percentage of how much health you have left. So at 100, so this is times by 100 divided by 1, so times 1, it's just equal to this. But at 0, the width would be 0, because this would be 0 divided by 100, 0 times 0, 0. So there we go there. And then its height was 10. The cooldown bar underneath the player is handled the exact same way as the health. It's just off place a little bit lower. Width, it's based off the tank width, and it's divided by the counter, that 160. So once you fill up, so instead of going down, it's filling up, by the way, because the counter is counting up, the health is counting down. Here's the collision that I've mentioned a few times now, actually. This is where it actually comes into play. So we take the two objects, and then depending on how they're called in the other functions, it might be the person who shot, the person who's the enemy. I believe that's the default that I try to use. It just decides if the masks overlay. So the pixels, if a pixel touches a pixel, it's a collision between just these two objects. So that's how that one works. So now we're going to get into the actual game loop finally. But it's not even the main game loop. I call it the main loop, but it's like the main loop. The game loop is within it. So anyways, the main loop, it takes if we're fighting a computer or not, for one, and then also what level we're currently at. If you're playing 2v2 or player versus player, the level's not going to matter and the comp's not going to matter, but they're there anyways in case you do play the computer. So I go ahead and set the mouse back to true, because in the main menu, I have to get rid of this mouse, like this mouse that we see here right now, because I use a custom cursor, that bullseye looking one. But whenever it's in the actual game, I would like to be able to see where my cursor is so I can move up to, let's say, close it. So I turn that one back to true just for convenience sake. The level is level, run true. This is what controls if the game loop is going to continue or not. We have some lost flags, so if player 1 lose, player 2, or if it's a tie. Can the player fire their missile? Is the game paused? This one's a fun one. She said it's a false, actually. It decides whether player 1 will be a computer or not also. So if you put this to true and then play the computer, player 1 will be a computer and player 2 will be a computer, and you can just sit back and watch them fight. It was used a lot for troubleshooting, actually. So I didn't have to actually do anything while seeing how the game ran. Continue is for whenever you get to the end of a match, you want to be able to continue. So we're going to start by initializing a clock, the PyGame time clock, set the frames per second to 60, and then these are the clock time and the timer, so the ones that you would see up top in the center. Loss count, it's, what was it? I think that's actually an artifact of a function that was deleted, so that actually can be commented out, honestly. Sorry about that. The time variables for the ballistic travel, so player 1's time, player 2's time, so whenever they fire, they can both be in the sky at the same time and it won't affect anything weird. What is it? Player 1 if they're in jail or not in jail for the times, and the time tracker for how long you can have a speed boost. Because the jail, you can only be in jail for so long, and you can only have the speed for so long. So now we're going to get into creating the tanks. So player 1 is created at a random location somewhere. What is it? 10 pixels to the left or 10 pixels from the center. And then player 2 is same, but from the other sides. That's just setting up the Y location. The ground is always set at 5/6 of the height of the screen. And we're going to, actually, it might be useful to set this to word wrap. Okay. The angles, the missiles they're going to use, which one's which. Yep, we covered those before. So here's going to set the velocities. So if it's at player versus player or computer versus computer, I set the, what's it called? The speed of the player 1 to be perfect. Or slightly better. So it'll have a 3.5 at level 10 and the other computer will only have 3. Just to see if player 1 would win more, but that's irrelevant. So player 1's velocity is always going to be this, pretty much 0.5 normalized to the screen. The player 2 will have the same speed, but the computer will have a variable speed depending on the level of the course or the match. The turret rotational speed is also just this, but I believe there was a reason why I had to separate it from those. Oh yeah, that's because sometimes these move and that was annoying. Alright, so the computer tracks the location 0. It initially wants to go there. Once it starts, it doesn't just go there immediately. It tries other locations. So here's the missiles, all the falling objects. So we got some missiles falling from the sky randomly, and then we got some health boosts randomly and some speed randomly. And this is the arrays that actually keep track of those objects as they're going down and being deleted. So the rainfall, so the array, the missiles within this array, they'll be how many in the air at once will be determined by this here. So if you're playing like player versus player, it's always just going to be 8 in the sky. But if you're playing the computer, it's going to start out real low at 3, but then get to 15 in the sky at level 10. So this is just setting up some fonts. I use Comic Sans because I think that's funny because people hate it. And they're all normalized. The the font heights or the font sizes to the screen. So this would be a 50, 20, 80 normalized to the screen. So that's how to read that. This array of strings is for, you remember whenever we watched the video of the gameplay, there would be player option or player one options, and then it would have : simple missile. If the option currently was simple missile, big missile, and all that. This is what pulls, this is where it gets those words from. That way I don't have to have a bunch of different ones down there. It can just pull from this easily. So this is a definition within the definition, which was kind of weird, but I went ahead and did it that way, that draws to the screen. This is the main drawer of the screen. So we immediately start out with putting the background on there, because the way that PyGames works is first come, first serve pretty much, where the first thing you put will be overwritten by all the other things coming later. So the thing you want in the very back, you got to put that first. So we put the background up first, and then we initiate those draw functions above. I placed player 1 after player 2 because whenever you're fighting the computer, you would like to be able to see yourself instead of the computer, because if it was the other way around, the player or the computer would drive in front of you instead. So that's why that order is that way. So then we go ahead and draw all of the different objects falling from the sky, going through the arrays and drawing each one. These are missiles, so they would fall under the missile class draw definition. Each one of these. And so sorry about that. And so here's whenever we got to the end of a match, it would say press B to continue. That's all that is. It is just holding this like object of font and message. So if we lose, we go ahead and, sorry about that, a lot of stuff popped up. We go ahead and say you lost. The lost label for that, or it would post this, so it would say player 1 lost here, somewhere in the middle of the screen, and then below it, press B to continue. Player 2 lost, very simple, same stuff, except if you're playing the computer, or sorry, here's player 2, like if it's a real player, player 2 lost, same stuff. But if you're playing the computer, it'll say the computer lost, but at level 10, you actually get to beat the game. And you also got to press B to continue. If you didn't beat the game and it's just this computer lost, it'll also just hit B to continue. So, and if it's a tie, very unlikely, I've never had it happen yet, it'll tie game. The only way to do that is game out or run out the timer. So if it's the computer, sorry about this. There we go. Yep, this is what this is. So these, I divide by 0 at one point, and it messed a lot of stuff up. See, where are we at? There we go. Player reigns. Let's take that. If player reigns was 0, like we didn't shoot out any Hell Rain missiles at all, we would be dividing by 0. And that would mess it up. So that's all this is for. And then this is all the stat F strings that we use to display the stats. And then we split it to the screen. So we create it there, and then we draw it here. And that's all that is at the very end of a match. So it's still underneath that lost kind of if statement and whatnot. Yeah, if lost. Yep. So here's where we draw write the numerical, the top left and top right statuses of the player. We player health with an F string, what the current number is for it. If it's the computer, we'll do computer health, and if it's the player, we'll do player health. And here's where these options that I was mentioning earlier come into play. Player 1 option, it'll do options, player 1 options -1 because it's indexed at 0. writes in black. If the computer, we say computer option instead of player 2 option, kind of similar stuff as before. And this is the game timer. It follows the same sort of format as the cooldown and health bars. It'll just be a normal bar being drawn to the screen, and then a bar that's going to change depending on the timer. So it's going to remove, and it's going to slowly get lower and lower and lower. And this is for the numerical top center timer up there, where it's the main time is 180 minus the clock time, and it outputs that. And for the level, if we're playing a computer, it just pulls the level, says level, and we go like that. And then this display update is just to pretty much say, okay, we got everything we want, update, done. Cast all that to the screen. So now we're actually in the real game loop. This is the actual game loop, not just the main loop that kind of happens. So we're going to progress timers nonstop. And so immediately we want to be able to kill the game if we want. So this is the quit, which would be this button up here. So if somebody clicks this button, it'll kill the run, make it false, and it'll return it to the main menu. And then also if somebody wants to pause it by hitting P, it'll initiate the pause. And this is just, if it's false, it becomes true. If it's true, it becomes false kind of statement. So if we're not paused, we're actually going to do stuff. We're actually going to redraw the window, which was this whole function here, redraw window. So that's quite a lot in this one little statement, but that's all that does. So we're going to go ahead and say if the game ends, like the timer runs out, which is based on the distance on that bottom bar, whoever has the most health wins. If it's the same, tie. And then we do a loss count of 1. The loss count just sets in motion a... Actually, I don't think it's used, honestly. I want to say that it was a artifact of a previous rendition where I would have it go for about 5 seconds and then clear itself. But now I have the hit continue. So those are actually unnecessary. Sorry about that. If the player runs out of health, it starts in game. So if player 1 runs out of health, we get a player 1 loss equals true. It starts all that stuff. Same for player 2 and the tie. So unless we hit B, which flips the continue right down here, it'll continue to do this screen right here. It'll just continue to sit there at that, where you just see that screen that says press B to continue. And then if you lost, if player 1 lost, we just go straight back to level 1. If player 1 won, we get to progress in levels. If a tie, I decided to make a tie technically a win, so you get to go ahead. And if you go above level 10, so you're going to level 11, you're not. You're actually going back to level 1 because you beat the game. There's no more after that. And then we main loop all over again. Back to the new level, the comp, and all that. And so this is just another, while you're in that blank menu where it says press B to continue, I want to give the option to be able to hit this exit button also. And so if you do hit that, you return it to level 1 though. So if you won and you hit this X, you actually lose your progression. So keep that in mind if you're playing for real. Here's where we progress some more timers for the clock time. So they're outside of that window up here where in that press B to continue, the timers don't keep ticking. So they're outside of that. Here's just an array of keys that have been pushed. And so that way you can push multiple keys at once and it'll actually run that too. So you can move left and right and adjust your turn at the same time, not just move left or right, then adjust your turn. So we move into player 1 controls. If they're not in jail, they can move. And so their movement is based off of the A and D key for player 1. So if the player So what this is saying here, sorry, it is if the players was to move in a direction, would it take them off the map, essentially? And if the answer is true, we're not, or if the answer is false, then we're not going to be able to, or it's true, we're not going to be able to do this. Sorry, if it's less than, sorry. So if the player would have traveled and you would stay on the screen, then you're allowed to move. But if you are not able to stay on the screen, if you were to move, you're not allowed to travel in that direction. That's what keeps the player in bounds of the screen. Because if not, you could go forever off into nothingness. And then the same for the other direction. The turrets work where only if you're within the range of... so I had to use the angles 225 and 445. They're essentially just... If you imagine directly up being 0 angle, negative 45 and 45. So 45, negative 45. And then that's how they work. But PyGame doesn't use that, so I had to adjust accordingly. But it's essentially, if you were kind of the same as this, if you're not going to pass that location, if you were to move, you're allowed to move. But if you are going to pass that angle, if you were to move, you're not allowed to move. So that's what keeps it in the bounds. So if the player has firing capabilities, so their cooldown is at 0, they're allowed to fire. We go ahead and assign the angle currently to the angle fire. So that angle fire is the angle that's used for all of the trajectory calculations. Because if not, if we use the current angle as you're firing the missile, as it's in the air, and you change your turn angle, it'll change the angle mid-flight to what that initial condition would have been there, and it just gets all kinds of messy. So that is an extremely crucial part of the code, actually. Then we just fire. This is what fires it. You get your player 2's location, essentially, which is used in the fire definition under tanks class. And then your option that's returned, so your next option that will be available to player 1. And then once you fire, so let's say if it's true, let's say fire's true right off the bat. You can't do this. So something needs to change it to false. So we change it to true, saying that you fired. Firing is happening right now as we speak. So no more firing can happen until we set it to false. So we got the path history, which is we just clear out the old one, and I'll show you what this is used for in just a second. So we have player 2 controls. Big surprise, they're the exact same. The only difference is we use left, right, up, down instead of the WSDW keys. So and right control for the fire instead of space. Same exact stuff though. And then we clear the keys that have been pushed so that the next round they're a fresh batch. So if you push A, it doesn't keep holding A essentially. So I'm going to skip computer logic just for a moment. So one time I'm going to go out of order to explain the firing portion. So we're going to pass the computer stuff, and we're going to go to firing 1, which is player 1's firing sequence. So if it's option 1 and 2, we progress the time because those operate with gravity, and gravity is affected by the time that it's been in the air, so we need to progress time. Points is going to pull that path missile function, or path function, which tells us the location, the XY locations of the missile being fired. And then as long as it's more than 1 or none or something like that, if there's any information, we append it to the points. And so that's what we actually use to draw that curved parabolic line. And that's what all of this is for. And then I believe this 20 here is so that it's not a continuous line. It disappears as it goes along. So it's a fixed length of 20 locations. And then if it's more than 20, it starts pulling off those last bits. So that's what creates that nice little... it's like following it at a delayed travel. So, and then we're going to move the missile. That's one of the very key moments of it. So it's going to take in this new T value, move it, new T value, move it, new T value, move it, all that. So if player cooldown is at 1, so that means that our little blue bar is filled all the way up. We're back to cooldown 1. We're ready to fire. We're going to reset the timer to a 0. And we're going to set fire to false so we can actually fire our missile again, whichever option it is. If it's Hell Rain, very simple. Rain actually takes care of a lot of that stuff. So we just hit Rain. It does what it does. We've already covered it. And then it resets our time or our flag for firing at the end of it. Heat Seeking, it's a bit of a time dependent, so we got to keep doing that. And then we do heat, which we've covered before. Same thing, timer 0, cooldown 0, we get to fire again. And for the jailer, it starts the cooldown, and we apply jail to them. And we get to, since there is no jailer method, there doesn't really need to be one, we just hit cooldown instead to start that counter here instead of within the tanks class. And same thing, once it's 0, we get to fire again. Firing sequence 2 is the exact same, actually, except where it says player 2, it says player 1, where it says player 1, it says player 2. So we're going to go back up to the computer. So now let's say the computer's playing, and this is the player 1 computer activated, so we're not going to cover this one. This is pretty much perfect play, though. So the computer we're going to cover is this, but degraded due to level factors. So all of this was the same. This whole block here, exactly the same. So if it's the computer, we're going to do this instead of letting it do all this stuff. If it's not in jail, we can move. If we're tracking the health tracker and speed tracker, which we'll cover later, then we're going to figure out which one of these is closer to us. So we figure out the hypotenuse length of the distance from current location to the health that's fallen from the sky. And then we figure out the same thing for the speed. So if the health is here and the speed's way up here and we're here, we're going to be closer to the heal. So it's going to have a lower distance to heal than it is going to have a distance to speed. So in that example, this would be the if statement that would go through because heal is closer than the speed. And all we're going to do is just increment our x distance to try to reach that speed or try to reach that location. And then once we're at that location, we're kind of at this moment where nothing happens. Like, you know what? It's hard to explain. I suppose it might be doing like this really small, like back and forth, technically, between one pixel, like back and forth 1 pixel, or it may just be set directly at a fixed location and it can't move after that. But it works really well for going to a location. And then same if speed is closer, it'll go to the speed locations instead. If it's not tracking those, like let's say the level factor gave it not that, so it has nowhere to go, it picks a random location from comp track, which was in the somewhere above that we covered earlier. It'll find a random location and just go there. That way it's at least still moving, and the player can't just hit like a standing target, which would be a little easy. So it aims, I explained it in the design. I couldn't mathematically derive it based on what I used, not easily. So what I went with was I figured out the distance that it would be if I was to fire it at 45 degrees full power, which the power is always the same. So take that distance, let's say it's here, and then the tank is here. So if I fired at 45, it'll reach here. If I fired 0, which is straight up, it'll go here, which is 0 distance. So the distance between here, that percentage, like 0 to 1, can correspond to 0 to 45. Its ratio is the same. So that's the way I went with it. So if we're halfway between the max distance and 0, the tank distance, it'll shoot between 45 and 90, or 45 and 0, which is 22.5. So it'll fire at that angle. And it's the same thing. It it just tries to find that angle right there. So it moves a little bit into that direction, and then maybe it's doing that 1 pixel like wiggle, but you can't notice it. And then this is if the tank is in front of the tank, and this is for if the tank is behind the tank. So positive 0 to 45, and then here's the the 0 to negative 45 range of angles. The level comes into play here. So as I said before, the angle fire is what actually the computer uses to do all the calculations for firing. And so at level 1, we're going to be adding a whole pi divided by 8, or 22.5 degrees of randomness, left or right or clockwise, counterclockwise, to it. So it can be firing all kinds of badly. It might be in its favor, and it might not. But at level 10, this whole factor goes away, and this is 0 to 0. So we're plus 0. So the angle is actually the perfect angle, or at least as far as I can calculate to be the perfect angle. Then we just fire like normal, we set the true like normal, and we clear its path history just like normal. And so now we can pass the firing 2 sequence because it's the exact same as firing 1 sequence, and we get into a couple of timer trackers. So the jail lasts for 5 seconds. At 5, it brings it back down to 0, and the player is free from jail. Its jail status is false, and the exact same for player 2. Something very similar with these speeds. Your speed lasts 10 seconds. The moment that you get speed, it starts incrementing it up by 1/60th of a second, which this is 60 frames per second, so it's 1 second to 1 second as far as we can tell. And so by saying 10, I actually mean 10 seconds. And so once it goes over 10, drop this number back down to 0, and we set our velocity back to the normal velocity that we would always have. And then the player speed back to false, so we don't have the speed boost anymore. And the exact same for player 2. So now we're going to get into the falling missiles that are just randomly coming from the sky. So they come in waves. So at the beginning, let's say there's 3, I believe, for if you're playing the computer. So there'd be 3 objects in this list, or 3 missile classes in this list. So it will not be equal to 1. So none of this happens. But once they're falling, they do get removed, as we can see whenever they collide with stuff. So once they hit 0, and whenever it first starts, there's nothing in it. So initially it sees it's 0. So we're going to go ahead and for level 8 and more, we get the only difference is we use the big missile index. That's all. But same stuff happens. And then it's based on the rainfall, which we covered before. So it's like 8 down here, and then 3 to 15, depending on your level up here. And so it appends them, this missile we just created, whatever many of them, into the missiles file. And now we're going to go and test all of those missiles to see if, well, for one, we're going to go ahead and they're missile classes. So we're going to use the missile class definition fall, which is straight downwards fall. Then we're going to test if they hit the ground, delete them. If they hit a person, this is what all this is for. If they hit a person, we delete them also, and obviously take away the health if need be. One thing with the computer doesn't lose any health. So whenever you're playing the computer, just assume that if you're playing 2v2, it's like the environment is attacking both of y'all. But if you're playing a computer, it's pretty much the computer's environment is attacking you. So the computer doesn't take damage, just you. Which makes it really hard on level 10 whenever it's the big missiles falling. So same idea with the health. The healths fall in batches of just a single health at a time. So there's only ever one health on the map. And so whenever there's 0, like say it hits the ground and it gets deleted, we initiate a new heal at a random location, and we add it to the heals array. And then we just test if it hits the ground, remove it. But every time it's removed, we need the computer to think, like, do I want to go for the next one or not? That's what these player 2 tracks, the player 2 heal track is. And so if it's 0, it'll go for it. If it's anything but 0, it will not go for it. So at a higher level, so let's say level or a low level, say level 1, we have 0 to 10 minus 1, 9. So there's a 1 in 10 chance of it actually wanting to go get that health. And if it doesn't want to go get that health, that's where this comp track comes into play, where it'll pick a random location on the map from 0, left side, all the way to the width on the right side to go. And then it just travels there randomly. And then we just follow the standard collision if it is player 1 and player 2. So both players, if they're stacked on each other, can get it. If it hits player 1 only, player 1 gets healed. He gets the health buff, saying that he collected them. It takes away the health. And then we assign new trackers, all that. And then speed, it's honestly a copy and paste, except everywhere the word speed is, or everywhere the health is, I put the word speed. It's really that simple because it follows the exact same thing, and the velocities instead of health are changed. So it's increased by 2 times. So every time you pick one up, you can get 2 times the speed, and they do stack. And then the same thing as before, the computer decides whether they want to go get it or not. As you can see, the player 1 speed track is there, and that's only for the computer versus computer version. So we're going to go ahead and get past all that, and then we're going to update all the different things that we've done up top. And now, this isn't really needed. It's just so it doesn't look dumb whenever, let's say you have 1 health and you get hit by the big missile, to show that you have negative 19 health, because that's what it'll show at the very end. So this goes ahead and just sets it to 0 no matter what, whenever you lose. So that's all that is. Now we're going to go into if the game is paused. So all of this, everything we just covered in the main game loop, was underneath, where is it at? The if paused, if not paused. Everything that we just covered was the if it's not paused. So we go all the way down here on this one little bar, and then we find, if paused, okay, we're going to do this, which is just, it's going to display on the screen, paused, with the background still on there and everything. And then it's going to blit that to the screen and update. So that's all it does. And since this is one of the last things, it's the main thing you'll see. So we're out of the game loop, and now we're going to go to the main menu. So we're going to take the level, which is level, and so that's from the very top all the way up there, whenever we defined it to be 1. So it takes that. The tutorial is false because we're going to be on the main menu, not the tutorial at first. And so here's just the font that we'll use for the title. The run is true for the title or for the main menu loop. And this index is going to help us go through the different images within this start folder. This is all of those spinning tank GIF images that we're going to cycle through. So this is more of just, these are the buttons, sorry. So we go ahead and start with the title. Just who do you want to go to war with? That's what you see whenever you first start it up. And then you see this button here, which is the computer button. So we have the rectangle that controls it and the font that's on it, and then what's written, same thing for the player, and then down in the bottom right is that tutorial button. And so we're going to draw, this is going to be a function to help draw the text. And so we're going to go ahead and, sorry about that. This is the tutorial image under assets. It's that Microsoft Paint image that you saw whenever I opened up the tutorials during the other video. That just shows you how to play, what to do, what to avoid, that kind of stuff. And so that's just the image that will display if that's it. The cursor, so this is the location of the cursor. So that's all that is. So whenever we click on it, it knows that we're on that location of the or the XY coordinates of that cursor. So here's the main menu loop. So that run controls it. We set the mouse to false. So I have that crosshairs cursor that I use. But if I didn't, we would see, if I didn't set this, we would see this mouse and the crosshairs at the same time, which is just weird looking. So I got to turn off the actual computer mouse while on the PyGame screen. This is the background for the spinning tank. It cycles through all 300 and something images, and we blit that to the screen. And then we index one more, boom. So once we get to like, I don't know, 1,000 something, it's still index moduloed to that. So we can let it spin forever. And it'll just go back to image 1 whenever it hits the end. So here's all of those buttons being actually casted to the screen. That's all that is. We use that draw text definition we kind of put up there just to help out a little bit. Here's where we actually take key inputs. So quit, always got to have that. That's the big red X up there. If we hit that, it'll actually kill the game fully. And here we go for if we click on things. So if we click on, if it's not in the tutorial window, we're allowed to click, I should say. If we click on, sorry about this. So rectangular 1 would be the computer one, the computer button, and then rect 1 or rect is the computer, and then the rect 1 is the player one. So we're going to set the computer to false because we're not going to be playing a computer, and then if we want to play the computer, we'll set it to true, and it will run the main loop, which is the game loop. So if it's rect 2 is the bottom right, the tutorial one. And so this is the if it's true, set it to false. If it's false, set it to true kind of statement. And if it's false and you set it to true, we now can run this, which it just displays that image scaled to the whole screen. And we also need to remember to put back in the button so that we can actually click on the button. So these two lines is just to add that button back again, because if we blit this over this, we won't see that. So we got to blit it after again. This is just the center of the cursor, and this is the blit of the cursor. So the image cursor, the crosshairs, and then the cursor rect is the location for that. So that's what those are for. And then we update to actually cast all these images to the screen. Whenever we hit quit, we're actually turning this to false. So that means this ends, so we can go past that onto this line, and we PyGame quit, but we also system exit. If we PyGame quit, we'll get a few errors in the terminal. I believe it has something to do with it's trying to run this again. I don't know why it tries to, but something weird happens. But if we system exit also immediately after PyGame quit, we don't run into that error at all. So that's beyond my knowledge as to why that is the case, but it does fix the issue. And then, so the first thing that even happens, which is funny because it's the absolute last line, this is what actually starts the whole process. Because nothing else on this bar, on this like tab line, even runs. We have definitions, got a couple definitions, and we have some statements, but nothing's actually running. We have a lot of just setting up images and all that, importing, but that's all that's actually on that bar. So that last line is actually what starts the whole process. So that was a very long-winded explanation of the code. If you have any more questions, please reach out and ask. I'll be happy to answer anything you got. And that concludes my discussion for the code. Have a good day.